Everyone, let's try to solve this quantum mechanics problem where we have been given a wave function a power minus lambda mod of x e to the power minus iota omega t, where a, lambda, and omega are some positive real constants. Now we need to normalize this wave function, and we have to determine the expectation value of x and x square. We have to find the standard deviation of x and then sketch the graph of mod psi square as a function of x and mark these 2 points, and we'll explain while we solve it, then we'll explain why these 2 points are very important. And we have to find the probability that the particle would be found outside this range, these 2 points. Okay, we'll try to solve it. And now one more thing to mention is that this wave function is for the potential, which is actually the Dirac delta potential. Okay, if you are not aware about the quantum mechanics, then that's completely fine, but I'm just for the sake of completeness, I'm telling that this wave function comes when we take the Dirac delta potential like this, and that's not the thing we need to know here. We'll just try to solve the problem what have been given. So we have to normalize this wave function. Okay, for the normalization, we use the condition minus infinity to plus infinity psi xt mod square would be dx equals 1. That means the particle must be somewhere where this psi square is actually the probability density, and psi square is psi star psi, so which implies minus infinity to plus infinity psi star xt psi of xt d of x equals 1, where psi of xt is the complex conjugate of the given wave function, where we need to replace iota by the minus iota and don't do anything with the real part of the wave function where there is no iota. So which implies minus infinity to plus infinity a star e power minus lambda mod of x. I didn't do anything with the real part, e power, but iota will be replaced by the minus iota, so it would become iota omega t, and there is a wave function psi a e power minus lambda mod of x e power minus iota omega t d of x equals 1. Now this a and a star will become mod a square minus infinity to plus infinity. Now this will go with this thing because it would be e to the power iota omega t minus iota omega t, so that would be 0. E to the power 0 would be 1, so there remains only e power this part and this part, so minus 2 lambda mod of x d of x equals 1. Now there's an important property of the even function. Since this is an even function, we can replace integral minus infinity to plus infinity into two integrals. Okay, it would be 2 times 0 to infinity e power minus 2 lambda of x d of x equals 1. This is a property of even function. Okay, if you don't know it, just learn a bit about it. So which implies 2 times mod of a square, and this integration would be equal to e power minus 2 lambda of x divided by minus 2 lambda from 0 to infinity equals 1. So let me move to the right, which implies twice mod a square. This 2 will actually go with this 2. This 2 will go with this 2, so there remains only minus times mod of a square and then divided by lambda and e power minus infinity minus e power 0 equals 1, which implies minus mod a square divided by lambda. It is 0 minus 1 equals 1, so this minus will combine with this minus, so it would be mod a square equals lambda, which implies a is root of lambda. So this is the normalization constant. We normalize the wave function. Now let's move to the other part, okay, which is the b part. What is b part? We have to find the expectation value of x. Let's find the expectation value of x. The basic definition of expectation value of x is integral minus infinity to plus infinity x into probability density, which is psi square d of x equals, okay, let me write it downwards. So this is the expectation value. So we'll directly substitute minus infinity to plus infinity x and psi square. What is psi square? We know now the psi square is this part, e to the power minus 2 lambda mod of x d of x, because psi star and the psi will give a psi square. So it combines whole, this whole thing is the psi square without dx, okay, leaving the dx part. So there remains mod a square that will be taken outside. So because this will go with this thing, this will go with this thing, there remains only these two parts, and this we took these two outside, and there remains that part. Okay, now we know mod a square has been calculated here, which is lambda minus infinity to plus infinity x e power minus 2 lambda mod of x dx. Now since this part is an even function, and this is an odd function, and when even function multiplies the odd function, it becomes odd function. And whenever there is an odd function from minus infinity to plus infinity, that would be 0. Okay, so that's a very important property, you must learn about it. So expectation value of x is actually 0. Okay, so which implies expectation value of x equals 0, because inside the integral of minus infinity to plus infinity we have an odd function. Now let's move to the other part, which is expectation value of x square, which is the c part. Now the expectation value of x square says the basic definition: minus infinity to plus infinity x square psi square of x d of x. Okay, so which implies expectation value of x square equals minus infinity to plus infinity x square. Now this is a psi square, let me write it. It is mod a square e power minus 2 lambda mod of x d of x. Am I okay? Okay, so x square, expectation value of x square equals, let's take this mod a square outside, then there remains minus infinity to plus infinity x square e power minus 2 lambda mod of x d of x. Again, this is an even function. If you see it carefully, this is an even function, x square is an even function, and this is an even function. Even and even, when even gets multiplied by the even, it becomes even. Okay, that's also an important property. Just go and have a look on this property. So it would be written as 2 times 0 to infinity. There is no need to write from minus infinity to plus infinity. If the inside we have in function, we can write that as 2 times. Okay, 0 to infinity x square e power minus 2 lambda of x d of x. Now we have to do integration by the parts. This is the u function and this is v function. I don't know how you do the integration of parts, but I'm going to tell you a very easy method to solve any integration by parts. Okay, so let's see. So you have to write it here u and then v, but remember this u is u as x square, and this v is not this function, but rather it is integration. Okay, so actually this u is actually the integral of e power minus 2 lambda of x. Okay, whatever it is, when you, so I should not write v here. Okay, so you'll get it. See, so u is x square, first thing, then in place of v we don't write this, but it's integration e power minus 2 lambda of x divided by minus 2 lambda. This is actually the v I am writing. Okay, so you have to differentiate this part and you have to integrate this part. That's very simple. So its differentiation is 2x, its integration is minus 2 e to the power minus 2 lambda of x divided by minus 2 lambda. 2 lambda is there would be minus 2 lambda again, so it is 4 lambda. Okay, do the differentiation again, so it is 2, and it's e power minus 2 lambda of x divided by 4 lambda into 2 lambda, which is minus probably there is 4 lambda square and minus 8 lambda cube. Okay, so now its differentiation is 0, and it doesn't matter what it is, because we're finally multiplying these two things. Okay, so I'm again telling you, here you have to write the u function, then here you have to write v, but down the v you have to write the integration of this thing. So it is e to the power minus 2 lambda of x divided by minus 2 lambda, then again do the differentiation of this part and do the integration of this part. So e to the power minus 2 lambda of x divided by minus 2 lambda into minus 2 lambda, which is 4 lambda square. Then again do the integration, e power minus 2 lambda of x divided by 4 lambda is there, 4 lambda square is there, then again minus 2 lambda will be multiplied, so minus 8 lambda cube. Now we'll write this integral as like this. So expectation value of x square equals 2 times, and mod a square have been already calculated above somewhere. Here it is lambda, so it is lambda. Now write the integration like this. Now multiply these two. Okay, x square e power minus 2 lambda of x from 0 to infinity. Now second term would be is there anything we forgot? Yes, minus 2 lambda, because this whole thing is v. Okay, then minus times 2x, this is this part and this whole part, e power minus 2 lambda of x divided by 4 lambda square. Okay, this is the second part, 0 to infinity. Then there is again the third part, this part and this part. So now this term would be positive. First term is positive, second term is negative, third term is positive. So 2 times e power minus 2 lambda of x divided by minus 8 lambda cube from 0 to infinity. Okay, now let's try to solve it on this page. So which implies mod of expectation value of x squared equals 2 lambda is outside. Now we need to put here first lambda and 0. Okay, so what will happen when we give infinity to this and infinity, it would become minus infinity, so it will come down, but this will decrease more than this, it becomes 0, 0, minus, and when we give 0 it becomes 0. Okay, and there it is minus, don't get confused, it's minus here, and minus again when we give infinity to this it becomes infinity, but when we give infinity here in place of this x, it becomes 1 divided by e to the power, but that would decrease more faster than this and it again vanishes, so 0 minus 0. Then there remains only this term plus 2 times e power minus 2 lambda of x divided by minus 8 lambda cube from 0 to infinity, from 0 to infinity. Okay, so which implies 2 lambda. Now 2 2's 4, 8, so it would be minus 1 by 4 lambda cube and e power minus infinity minus e to the power 0. Okay, because we put infinity here and 0 in place of x. I know, you know all these things. 2 lambda minus 1 by 4 lambda cube, it is 0 minus 1, and which implies expectation value of x square, expectation value of x square, expectation value of x square. So it would be minus minus would be plus, so it's 2 lambda divided by 4 lambda cube. So 2 2's 4, lambda lambda will go, so there remains only 1 divided by 2 lambda square, and hence expectation value of x square is 1 over 2 lambda square. Okay, now we have to do the another part, which is standard deviation. Probably, yeah, we have to find the standard deviation of x. So the d part is standard deviation which is we know the variance sigma square is given by the expectation value of x square minus expectation value of x whole square. So we already calculated both of these two things. Expectation value of x square is here, 1 divided by 2 lambda square minus expectation value of x we already calculated, which is 0. So 0 square, which is standard deviation variance, actually this is variance square, equals 1 over 2 lambda square. So now we can write the standard deviation, which is sigma, which is 1 divided by root of 2 lambda square, which implies standard deviation is 1 divided by lambda root of 2. This is the standard deviation. Let's move to the another part where we have been asked to plot the graph of this psi square versus x. And since we know that psi square is actually psi star psi, and we already calculated above, mod of a square e to the power minus lambda mod of x. I want to mention here certain things that we already evaluated this mod a square, and it is probably equal to the lambda. If I remember, it's probably were here. Its mod a square is lambda. So let's put it here. So it is actually lambda e power minus 2 lambda mod of x. Now about this function, it is an even function, and this is some positive constant. This, if we plot this psi square versus x, it must be symmetric about the y-axis. So it must be symmetric about the y-axis. At x equals 0, the value is lambda, because e to the power 0 is 1, so it is here lambda, or we should say mod a square. That's completely fine as well. So the plot is symmetric about the y-axis. Why is symmetric about the y-axis? Again, this is an even function. In mod of x is x when x greater than 0, and it's minus x when x is less than 0. In the both ways, when we increase x on the right side or the left side, that would decrease the value on the both. So this would be symmetric. The plot would be symmetric about y-axis. Now one thing we have to mark two important pointers, which is sigma x, expectation value of x plus sigma, and expectation value of x minus sigma. So but since expectation value of x is 0, we already evaluated it. So this is expectation value of x. From here it is x, and from here it is psi square, and plus sigma would be here, and minus sigma would be here. You can calculate here what is the value of sigma. Okay, so yes, this is the area, and now these 2 points are very important, because whenever we do the measurement in quantum mechanics, we don't get actual measurement, but we get spread in the measurement, and that spread is actually calculated through this standard deviation. Okay, so this is the spread, and this spread is always there, that is inherent in the system because of the uncertainty principle, because uncertainty principle is sigma x, sigma px greater or equal to h cut by 2, or it's like del x del px greater or equal to h cut by 2. So these two must be conjugate to each other, and there is actually the relation. This is a standard deviation, this is a standard deviation, so this is the uncertainty in x. So standard deviation must be connected to the uncertainty values, and yes, there is a relation, which is actually very important relation, which says that variance or standard deviation square is equal to expectation value of uncertainty in x square. This is actually equal to the expectation value of x square minus expectation value of x whole square. Similarly, we can write for p, sigma px square equals sigma del px whole square expectation value. This would be px square minus px this. Okay, so we can find the connection between the standard deviation and uncertainty in x, and standard deviation in the px and uncertainty in px. So this is always there. So this is actually the spread in the measurement, because if we have a system and we do the measurement on that system again and again, but in actual reality we don't do it again and again, we make actually ensembles of the system, exactly the same copies of the system, and we do the measurement, and when we see the measurement, we don't get a same value for each person. Like if we have a system and we do hundreds of the ensembles of that system, and every person does the measurement at exactly same time, the measurement doesn't come out to be single measurement, but there is a spread, and that spread is actually given by this, minus sigma to plus sigma. Now there is important probably another question which says what is the probability. So now this is a function of x, mark the point is this and this, and I also explained a bit about it. Now what is the probability that particle would be found outside range? What is the probability that particle would be found outside the range? Now we have two ways of calculating this thing. One is that we calculate the probability here in this region, and the outside probability would be 1 minus that. You understand? And or we can calculate directly probability here and here. So that would also be enough. Now let's calculate directly from outside region, because probability of finding in any two points would be equal to a to b psi square dx. So this is simply the probability. Now here we have two important things. What we have to calculate is that we have to find the probability from minus infinity to minus sigma psi square dx plus plus sigma to plus infinity psi square d of x. But since we know this is symmetric, so the probability here would be equal to the probability here. There is no problem in doing that. Okay, so the probability here would be probability here. So we can write it as 2 times minus infinity to minus sigma psi square d of x. Or we can write this way, plus sigma to plus infinity. It doesn't matter, but let's calculate this one. Maybe it seems more easy to calculate plus sigma to plus infinity. Now what we have, 2 plus sigma to plus infinity, and psi square is already mod a square and e to the power minus 2 lambda mod of x d of x. Is that okay? So and since we are calculating in the right region is plus sigma to plus infinity, so mod of x would be x there. So we can write it as 2 mod a square plus sigma to plus infinity. It's e power minus 2 lambda x d of x, because for the positive value mod of x equals x for x greater than 0. Now mod a square is already lambda. We calculated mod a square here is lambda. Let's put it here. So 2 times lambda and integral plus sigma to plus infinity e power minus 2 lambda x d of x. So this is the probability, and 2 into lambda, let's put it like that. Integral of this thing would be minus e power minus 2 lambda x divided by minus 2 lambda from plus sigma to plus infinity. So it is 2 will go, and lambda there remains only minus e power, just like that, e power minus infinity minus e power minus 2 lambda sigma. I put the value of plus infinity in place of x, and I put the value of sigma in place of x, and minus is there. This is it's 0, because it would be 1 over e to the power infinity. So it's 0 minus e power minus 2 lambda sigma. Now it would be e power minus 2 lambda, and sigma we calculated here 1 over lambda root 2. 1 over lambda root 1 over lambda root 2. Lambda will go with this thing, so there remains only e power minus 2 divided by root 2. You can put it like that, but let us simplify it a bit. minus 2 divided by root 2 into root 2 divided by root 2. So it's equal to e to the power, this would be 2 root 2 and like this, 2 root 2 divided by 2. So e power minus root 2, we can write it like 1 over e power root 2. It's like 1 over 2.7 to the power 1.414. You evaluated, the answer is around 0.24. If I remember, 2431. This is the probability, or in percentage it would be 24.31%. Okay, this is the probability of finding the particle in the region outside from minus sigma to plus sigma. What is the probability that particle would be found outside this range? This. Okay, so that's all in this video. Thank you so much for watching.